All right, so in this video, we are on to the fourth part of the sequences packet. All right, and we're really only going to be covering 2 pages in this video because some of the examples on these pages get a little tricky. All right, so number 25, it's saying given f of 9 equals -2, which function can be used to generate the sequence, this right here. Now, instead of using a sub n, they're just using function notation. They're using f of n. So let's first figure out what type of sequence we have going on here, and then I'll just kind of get back to what function notation means. All right, so if we look here, we're starting at -8, and then it's going up to -7.25, and then it's going up to -6.5, and then it's continuing to go up. Now, some of you may be able to look at this and say, well, it's going up by 0.75. If you're not sure, and even if you're not sure if it's arithmetic or geometric, you can always take a term and subtract the term before it, and then take that term and subtract the term before it to see if we're getting a consistent number. And if not, then check if it's geometric. Take a term and divide by the term in front of it. And then take that next term and divide by the term in front of it to see if we get a consistent number. Okay, so I'm going to start with arithmetic. I'm going to start with this term and subtract the term in front of it. Okay, so I just showed that in my calculator. I took this term and subtracted the term before it, and I got 0.75. Then I took this term and subtracted from it the term before it, and I still got 0.75, and I did the same thing with these 2 terms. So since I'm consistently getting 0.75, what that means is if I were to work forward, I would be adding 0.75 to get from one term to the next. So what this is telling me, let me just move this out of the way. What this is telling me is that my common difference, right, is arithmetic, and my common difference is positive 0.75. Okay, now normally we can see that these are not recursive formulas. It's all one rule, so we're going to be using the explicit formula. Now normally the explicit formula for an arithmetic sequence looks like this. But if you look here, instead of using a sub n, they're just using f of n. They're putting it in function notation. So I'm going to change this a sub n to f of n, which means I'm going to change this a sub 1, that's not erasing for me, there we go, to f of 1, which just means the first term of the function. Okay, now here I'm going to leave this as f of n. I'm going to leave this in terms of n. And then I'm going to plug in my first term, which is -8. And then plus, I'm going to leave this in terms of n, so n minus 1 times d, which we said right here, d, the common difference is 0.75. Okay, now if I look at this, I don't see that over here. I mean, I see these both say n minus 1. This says -8 and then plus 0.75 times n minus 1. This one says -8 minus 0.75 times n minus 1. And this one has the numbers in the reverse order. So none of these are matching up. So I think what we're going to have to do, let me just move this a little more, move it over here. I think we're just going to have to work with this equation a little bit. So let's see what we can do. So f of n equals, I'm going to bring down the -8, and I'm going to distribute the 0.75 into the parentheses. So that'll be plus 0.75n, and then minus 0.75. Okay, so all I did was distributed the 0.75 into the parentheses, and this is what I got. Now, if I combine my like terms, -8 minus 0.75 would be -8.75. So we have f of n equals -8.75, and I'm going to bring down the plus 0.75n. So now let's see if we see that. Yep, look at this right here, choice 3. Okay, this says the same exact thing as this, so choice 3 is our answer. Okay, now a little shortcut of what we could have done. See this in the beginning here? F of 9 equals -2. We could have replaced all of these n's with 9's, meaning we would replace any n you see in the formula with a 9, and see which one equals -2. Now, since we already know that choice 3 is the answer, I'm just going to jump to choice 3 so you could see this. So if I were to write f of 9, okay, so what I'm doing is I'm replacing this n with a 9. So I'd have to rewrite the right-hand side of the equation, but replace this n with a 9. So it would give me -8.75 plus 0.75 times 9, right? I'm replacing that n also with a 9. If I plug this into my calculator, I do wind up getting -2. So this checks out. If you tried the other ones, they actually wouldn't check out to give you -2. So you could also come up with the answer that way. Okay, so 26. When a ball bounces, the heights of consecutive bounces form a geometric sequence. So consecutive means they follow each other in order. So for example, like 3, 4, 5 would be consecutive numbers. Or 9, 10, 11, they would be consecutive numbers. They follow each other in order. Okay, anyway, the height of the first bounce is 121 centimeters. Okay, so A sub 1 is 121 centimeters. I'm just going to say the first bounce is 121. Okay, and the height of the third bounce, so it looks like we're skipping over the second bounce here, so I'm going to leave that blank. The height of the third bounce is 64 centimeters. To the nearest centimeter, what is the height of the fifth bounce? Okay, so here's first, second, third, fourth, and fifth. So based on the 2 they give us, we have to find the fifth bounce. Now what's important here is they do tell us that it's geometric, so it means we're multiplying to get from one term to the next. Now, we don't know what at this point, we don't know what we're multiplying by to get from one term to the next, but we know we're multiplying by the same number to get from the first term to the second term as we are to get from the second term to the third term. So if we don't know a number, we usually represent it with a variable. So I'm going to represent it with x. All right, so let's think about this. 121 times x will give me the second term, and the second term times x will give me the third term. So basically, if I take 121 and multiply it by x, and then multiply it by x again, it'll give me 64. Okay, so let me write that out. So 121 times x equals 64. Okay, so x times x is just x squared. So let's rewrite this as 121 x squared equals 64. All right, so to solve this, let's just get the x squared by itself so we could divide both sides by 121. So that gives me x squared equals 64 over 121. Now to get rid of a square, right, we just take the square root. So I'm going to take the square root. Oop, we changed it over to green here. Take the square root of both sides. And since the square and a square root cancel each other out, that's going to leave me with x equals, and then we know that we're going to write plus and minus because we, the square tells us there's 2 answers. And when you take the square root of a fraction, you take the square root of the numerator. So the square root of 64 is 8. And then the square root of the denominator, the square root of 121, is 11. Now let's think about this logically. We're talking about the height of the bounces. So we can't have a negative height. So really here we're looking at x being equal to 8 over 11. All right, so now that we know what we're multiplying by, we could easily find the fifth term. All right, I'm just going to organize myself here. I'm going to write this out again. So the first term we know is 121. We still have to find the second term. The third term is 64, and then we got to find the fourth and the fifth. All right, so if we did 121, I'm going to do this on my calculator, times 8/11, which technically you don't really have to do, but that would give us 88. So there's our second term. So then just to check, if we want to do 88 times 8/11, let's see if we get 64. So times 8/11, and yep, we got 64. So now if I take 64 and multiply it by 8/11, I wind up getting, let's see, this is a decimal. It's approximately 46.54. Well, it's actually 46.54 repeating. So I'm going to just round it on the paper because I think that's why they say to the nearest centimeter, what is the height of the fifth bounce? So this one is about 46.5. Now, if I take that exact answer that's in my calculator and multiply it by 8/11ths again, it gives me about 33.8. So to the nearest centimeter, that would be 34 centimeters. Alrighty, number 27. When that was on the Regents, I was like, wow, that's a tricky question. All right, it says the 8th and 10th terms of a sequence are 64 and 100. So basically what that's telling us is we know the 8th term is 64. We don't know the 9th term, so I'm going to leave that blank. And then the 10th term is 100. So basically we're missing the term in between them. Okay, if the sequence is either arithmetic or geometric, the 9th term cannot be. So we're figuring out which one of these answer choices can the 9th term not be. All right, so here's my plan. What I did was I wrote out what we knew 4 times. And I'm going to take these answer choices and plug them in to the missing term, one by one, and let's see which one doesn't make any sort of sense. All right, so let's see. We're going to plug in negative 82. That's the answer choice. That's choice 1. Choice 2 says negative 80. Choice 3 says 80. And then choice 4 says 82. Okay, so let's see which one doesn't work. Okay, I'm actually going to start right here with choice 4. Now, if you're not sure, the numbers are getting bigger. So if you're not sure whether this is arithmetic or geometric, remember, let's just take a term and subtract the term in front of it. And then take this term and subtract the term in front of it. If you get the same difference both times, this is arithmetic. If not, take a term and divide by the term in front of it. And then take that term and divide by the term in front of it and see if we get the same number each time. Okay, so I first started off using subtraction. I did 100 minus 82, and it gave me 18. And then I did 82 minus 64, and it gave me 18. So since these match, what that means is to get from one term to the next, to get from here to here, I'm adding 18. And to get from here to here, I'm adding 18. So choice 4 works, okay? That's an arithmetic sequence. So I'm going to cross off choice 4. All right, now let's go to choice 3. Now, in choice 3, I don't know about you, but I can clearly see that if I were to take 80 and add on 20, it would bring me to 100. But if I were to take 64 and add on 20, that would not bring me to 80. So really what we're looking for here is we're trying to see, is this geometric? Okay, if you weren't sure if this was arithmetic, you could do the same thing I did here. You could try subtracting them. But I think this one was a little bit more clear to see. So let's work our way backwards. Let's divide. Okay, so when I did 100 divided by 80, I got 1.25. When I did 80 divided by 64, I also got 1.25. So what that means is this is geometric. To get from one term to the next, I'm multiplying by 1.25, okay? So that's a consistent rule. So this is geometric. I'm multiplying by 1.25, so this one checks out. So choice 3 is not the answer. All right, now let's take a look at choice 2. Now, we know already that if we're going from a positive to a negative back to a positive, this cannot be arithmetic. There's no way you can add and get smaller and then all of a sudden get bigger. If your number's going down, you're adding a negative. If the number's going up, you're adding a positive. So the only possibility would be geometric. Now, without having to do this in the calculator, you can if you want, but I mean, look at choice 3. The only difference between the numbers here is that this one in the middle is negative. So doesn't that mean that instead of multiplying by positive 1.25, we're multiplying by negative 1.25? Okay, to go from here to here, we're just multiplying by negative 1.25. And same thing, to get from here to here, we're multiplying by negative 1.25. If you can't see that, you can rely on the calculator. Okay, so, I did it here with 100 divided by negative 80. is negative 1.25. Negative 80 divided by 64 is also negative 1.25. All right, so we know that, through process of elimination, choice 1 has to be the answer, but let's just double check. All right, so again, if we're going from a positive to a negative and then back to a positive, it's impossible to be arithmetic, so we can only try geometric. So let me just use my calculator and do 100 divided by negative 82. And let's see if we get the same answer as when we do negative 82 divided by 64. Okay, and what you can see here is, look, I didn't get the same thing. So this rule, it doesn't work. Okay, just trying to give it the old cross off. This one doesn't work out for us. So choice 1 is the answer. Okay, number 28 is very similar to 27 in the thought process. So why don't you hit pause and try this on your own, see how you can do. If you have to go back and re-watch how I did 27, do that, okay? And then once you try out 28, then you could hit play. Okay, so I'm going to start off this one the same way. They gave us the 18th term is 10. We don't know the 19th term, and the 20th term is 70. So I'm going to take these answer choices and plug them in one by one into each of these sequences. Okay, so I'm going to go right in order this time. So when we start with number 1, remember to go from a positive to a negative and then back to a positive. The only way that could happen is if you're multiplying by a negative. So this could only happen if it's geometric. So if you want to figure out, if this is a sequence that would work, let's take the 70 and divide it by the term in front of it. And then let's take the negative 40 and divide that by the term in front of it and see if we get a consistent answer. Okay, so we can see we do not get a consistent answer. Okay, 70 divided by negative 40 does not equal negative 40 divided by 10. Okay, so this negative 40 is the answer choice that doesn't work. So that's our answer right there. Choice 1. I would still go through the other choices just to make sure that they don't work. So I'm going to quickly do that. Okay, for choice 2, I'm definitely not going to even bother using my calculator. This one's very, I think, apparent to see. If you take 10 and add on 30, you'll be at 40. If you take 40 and add on 30, you will be at 70. Okay, so choice 2, definitely 40 works, so that's not our answer. All right, now 3, you may look at this and say, well, I have no idea if that's going to be arithmetic or geometric. So check both options. Okay, so in choice 3, first, if you're not sure if it's arithmetic or geometric, see if it's arithmetic. Do 70 minus this term and see what you get. And then do negative 10 radical 7 minus the term in front of it. Look, these don't match, so arithmetic is out. Now let's see if it's geometric. Do this term divided by the term in front of it. And you get approximately negative 2.6. When you take this term and divide it by the term in front of it, look, you get that same exact decimal. So choice 3, this does work. This is a geometric sequence. Okay, so choice 3 is out. Now, if you look at choice 4 says the same exact thing as choice 3. The only difference is, in this case, we're not multiplying by a negative to get from one term to the next. You're multiplying by a positive. So, I'll show it here on the calculator. I did 70 divided by the term in front, and it gave me positive approximately 2.6. And when I did 10 radical 7 divided by the term in front of it, it gave me that same exact positive decimal. So choice 4 also works. That's a geometric sequence. So choice 1 is the only one that doesn't work. Okay, and then finally, 29 is the last one we're going to do. So write an explicit formula, a sub n, for the nth term of the recursively defined sequence below. Okay, now if we look at this sequence, right, they're telling us the first term. This time it's not equal to a number. Okay, that's okay though. It's equal to x plus 1. And they're saying to get the nth term, take the previous term and multiply it by x. So since we're multiplying by x, this is geometric. So they want us to write the explicit formula. Okay, so the setup for the explicit geometric formula looks like this. So all we have to do is just fill in the components. Okay, so we want to leave this as a sub n, right? We want to leave it in terms of n is equal to, well, our first term is x plus 1. Now, since we want to multiply the entire first term by r, since this is a binomial, we have to put it in parentheses. If you forget to put the x plus 1 in parentheses, unfortunately, we'd only be multiplying the 1 to the r, not the entire x plus 1. Now the r is what we're multiplying by to get from one term to the next. So since here we could see we're multiplying the previous term by x to get to the next term, x is our common ratio. And then we're just going to raise that to the n minus 1 power. So there you go, that's it. Okay, so then the second part, for what values of x would a sub n be equal to 0 when n is greater than 1? Okay, so let's see here. So basically, we want to know when would a sub n be equal to 0. So let's just take this and replace it with a 0. So I'm going to write this as 0 equals all of that. All right, well, we know that when we have an equation set equal to 0, usually we factor it and make a t-chart, but this is kind of already in factored form for us, right? Isn't this one factor? And, this x to the n minus 1 is your other, really. So let's just make a t-chart. Let's jump right into making a t-chart. Now over here, I know a lot of you guys just jump right to writing x equals -1. I'm okay with that. If you want to show the work, you could set your factor equal to 0 and subtract 1 from both sides, but you do not have to show this at all. Honestly, you can just jump down to this. You don't need any of this. Okay, and then, here, if you want to do the same thing, if you wanted to set this equal to 0. Now, in order to solve this, I'm just going to have you think about it logically. We're trying to figure out what value could x be so that when you raise it to a power, it's going to be equal to 0. Well, let's think about it. Isn't 0 to any power, really? Other than 0. That's why they're saying n has to be greater than 1. But anyway, isn't 0 to any power like 0 to the first power is 0? 0 to the second power is 0. 0 to the fifth power is 0. So really, this x, in order for this statement to be true, has to be equal to 0. All right, so then those are our two answers. And one thing I want to point out, don't think that because this is negative, this can't be an answer. It doesn't say x has to be greater than 1. Or actually, don't think that either one of these can't be the answers. It says n is greater than 1. And they were just saying that so that this would be technically correct.